Okay, so we can start right now, and okay, fine. Speakers today, we are here. So Andras Peror, myself, I'm a global account manager at the GMI. 20 experience in companies for market for machine process automations, and was responsible for European market. Now I'm responsible for global account worldwide. I'm a functional safety engineer. With me today, there is Massimo Pagani. He's our product manager and also responsible for customer support. And has a very long experience also in the electronic department. He's our, let's say, joint between the sales and R&D department. So we support our R&D team for developing new products, new solutions. He's also a functional safety engineer. Just a few words about the GMI. So very quickly, and this company is producing intrinsically safe and SIL certified devices for main solutions, DCS, ESD, fire and gas applications for critical market like oil and gas, chemical, petrochemical, and so on. We have 40 experience, and we produce more than 40 experience. We produce completely in Europe and Milan, Italy. And we have a global presence in all continents through our offices. We produce intrinsically safe barriers, safety relays, isolators, power supplies, multiplexer, termination boards for DCS and PLC producers, hard multiplexer, surge protection indicators, and also we provide trainings for functional safety and EX applications. And we do have all kinds of certification necessary in this market, and also we are, of course, our product have been certified from different accreditation body, 15 functional safety management certification for the company, and also SIL3 systematic capabilities for the design of the product. Over 10% of our employees are dedicated for R&D, and also we reinvest a lot in our R&D team and development. We do have also 5 years warranty for all products. About production, we produce completely in Italy, in Europe, complete automatized production, complete traceability for incoming and outgoing products, and complete testing also. All products are tested 100%. And that's all. Also REACH compliant. Some numbers about our organization: different 10 offices in the world, 75 distributors, 200 people, 18 courses, functional safety courses, and a lot of installation. Some names for the customers divided by system vendors, EPC, OEMs, and end users. Okay, we do have a poll. I like that if you can answer to this very, say, simple poll. How important is SIL certification in hazardous area application for you? Just to say, to know what kind of, let's say, activities we have today at our webinar. So probably I don't see, not at all important. Okay, we leave it just 1 minute and we'll move on this webinar on the topic of today. Thank you for answering. Another few seconds and we'll stop. So very important for most of you is this the SIL3 certification for also for hazardous area application. Thank you very much for answering. Okay. Okay, I stop now. 1, 2, 3. Thank you. I want to share with you the results. So you see that most of you say that very important and also quite important is for the good. We can go on the topic of today. So it's a time for Massimo Pagani. Massimo, it's your turn now.
Thank you, Andrea. Thank you, Andrea, for your introduction, and welcome to everyone also from my side. In this GM International webinar dedicated in its first part to the smart relay in their real application. Well, we can start with our presentation. Let's start by introducing the concept of safety instrumentation system. SIS is a set of subsystems that make up the safety loop. And within this safety loop, we have field devices such as transmitter or sensor, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provides for limiting the current toward the hazardous area or to isolate the field instruments. And in turn, the signal sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS or the PLC-DCS system, which will decide on any action to be taken to make a plant safe. And again, power interfaces, as can be a safety relay, which will then act on a valve and on an actuator, which allow us to bring the system safety in case of need. But the main concept that needs to be understood is that every single element of the SIS must be sized with a SIL level, such as to allow us to obtain the overall SIL of the SIS required. All components of a SIF, including power supplies, to which we will dedicate a part of this presentation, must be safety related and have a SIL level. This helps us to have a safety loop and with the correct redundancy, a loop with high availability to the process. But let's start examining those that are a fundamental part of a SIS. Let's talk about safety relay. A safety relay can stop or initiate movement in a controlled, safe manner by opening, closing valves, start-stop motors, and so on. They must conform and adhere to the ESC 61511 industry standard. Not only oil and gas or process industry, but in general, safety relay can be used where a failure of the relay can cause serious accident to human, environment, assets, and or image. Well, but what are the typical cases where a safety relay is required? So typically, we must use a safety relay in all of those applications where the controller, the digital output card of a PLC, for example, is enabled to activate a field device due to its limited potential in relation to the voltage and current involved. Or in those applications where multiple concepts for the simultaneous activation of multiple loads is required. Or even in those applications where the safety function that the controller must perform needs to be inverted. But what is the difference from a standard to a safety relay? Please, Andrea, I leave it to you to explain this.
Yeah, that is simple, but not simple because the standard relay, usual relays we may find in the market that were not be used in the safety because it is not certified. Of course, a relay, but it means that the design, the product, the failure is not certified, so there is not FMEDA in place. So, because a safety relay is a relay with a known and warranted ability to perform a given safety function. So there is a certain and assured percentage or probability that relay is able to perform that safety function. So what is safety function? Safety function is the ability to reach a specific safe state on demand. And the most simple, or let's say usual application for safety relay is a valve opening, closing, of course. So open release valve or activated fire extinguishing system. That is a typical application. We are talking about ESD, IPS, BMS, so application you know, so working in this market, where the safety function is a normal energize, and I want to, in case of alarm, in case of problem, the relay must de-energize to safety, DTS. That is the primary used, de-energize to safety, or de-energize to trip. So normal energize, I have to de-energize for safety. The other way around, fire and gas applications, most of the function are normal de-energized. So I have to energize to safety, ETS to energize to trip. That is, those are the most common. So for that different function, you may have different relays to be used. And if we look at the single relays, of course, we say that a standard relay cannot be used as SIF because a standard relay has not made analysis in place, is not available from the manufacturer. So there are not, the failure rate is not certified while SIF relays. The estimated analysis means that every single component from the table you see on the right is has a certain failure rate declared by the manufacturer. So every single resistance, capacitor, inductance, and other components you use in the relays is certified, the failure rate is certified by the manufacturer. And the data for the relay itself, which is composed from a lot of components, is the result of this calculation based on all its components. So it's clear that the components inside the safety relays are not standard, and not our, let's say, step ahead quality-wise. And there are information like failure rates for safe failure, for dangerous failures, very important consideration, like MTBF, mean time to failure for dangerous, safe and dangerous failure must be really evaluated. So we move again, leave Massimo to the next slide.
Well, Andrea,
I repeat, Massimo, if you have questions, just write on your Q&A button on the bar. Thank you, Massimo.
Okay, thank you, Andrea. Well, let's look specifically at the difference between digital input relay and digital output relay. Digital input relays are those devices able to managing a voltage-free contact positioned in the field and communicate the status of this contact to a digital input card of a PLC DCS. A typical example is a proximity sensor, NAMUR type, which is fed and acquired through a galvanic isolator for digital signal. In this case, the sensor in the field is a simple contact free of voltage, which needs to be read and interpreted by our device, digital input relay in this case. But what happens if in the field we have a wet contact by a voltage, which can different values such as 48 volt, 230 volt, or 24 volt DC, and so on. In this case, a digital input relay cannot be used because its input front end is not available to accept external voltage from the field. In this case, we will have to use a digital output relay that is a device that, depending on the voltage that arrives at its command, activates or deactivates an output contact and communicates to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate two PLC DCS system placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while the digital input card receives the contact status of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? Well, first of all, we have to keep in mind that usually a relay is designed to switch important values of current, while usually towards a digital input system, the currents in play are very low, typically less than 100 milliamps. In this situation, we can face problems of oxidation of the relay contact. Therefore, it's essential to choose a safety relay with golden plate contacts, which allow us to switch thanks to its high conductive performance, even current lower than 10 milliamps. To deal with this problem, GEM International has equipped most of the relays of the new D5000 series with the golden plate contacts to make them available to this particular application. In addition, GEM International has developed a universal device able to receive at its input different voltage level, 24 volt, 48 volt DC, 110 volt DC, and so on, selectable via the switch, while the output provides a free contact voltage, optocoupled type, compatible with all PLC DCS systems, which ensure maximum conductivity even at a lower current. This specific device is specifically designed to work in this kind of applications where we have to communicate between two systems distant from each other, or where we have to signal to a system presence or absence of voltage. Well, now let's look at the diagnostic safety relays.
Yeah. Massimo, before going on the next, we have a question from one
Okay.
which is asking what is the reliability for this DI-DO relay? So reliability means, say, what is the duration of many years can last this relay, and this probably, don't know, we try to answer this. This maybe you can we can pose the next question. So it's this is 20 years lifetime for this relay is 20 years. So all our hardware is can last for 20 years without problems. Okay, we can go to the smart solutions now.
Okay, thank you. Okay, we speak about smart relay. These relays allow us to constantly monitor the load and the line in the field and report to our system if a fault is detected in the field. The diagnostic of these relays is active both in on relay condition and in off relay condition, allowing us to know the health of the loop, especially in fire and gas application. Why going for smart relay? Nowadays, full diagnostics is typically required along the full loop. However, many widespread systems do not support diagnostic inside their digital output cards, and smart relay make diagnostic available to systems that do not support it. In other case, many modern systems do support that digital output diagnostics. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. Or when the load for example, valve, beacon, sounders, etc., require more than 24 volt and or more than 500 milliamps, relay in this case are necessary. And yet when using standard relays, the digital output diagnostics dies at the relay codes and cannot reach the load in the field. As opposite to that, a smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostics. Even if a modern system can perform load diagnostics, their capabilities may be limited. For instance, air leakage monitor may not be supported, or extreme load, for example, beacons may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capability. Smart relay also introduced the possibility of mirroring a fault in the field directly to the digital output card of a system compatible with this function. Let's see more detail. What is the mirroring function on a smart relay? Well, this function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC. This situation is in both in the on state through the pulse test system and in the on state by reading the static return of current. The digital output card of a PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised digital output to see the fault in the field. This system, again, allows considerable saving in engineering costs, as it allows us not to use a dedicated digital input card for this purpose. For this scope, GM International integrates its range of smart relays with two models, the D5096S and the D5096S-100. But what are the differences between the two models? Well, the D5096S is a smart relay with fixed diagnostic with the possibility of mirroring a fault in the field directly to the digital output card compatible with this functionality. This type of relay is SIL-free for both normally energized and normally de-energized applications. And the mirroring function is performed through a change in impedance, but not all PLC DCS systems are able to correctly read this impedance variation. For this reason, the D5096S-100 variant was created. The D5096S-100 has the same diagnostic functions as the D5096S, but as an universal mirroring system compatible with all PLC DCS systems, since inside the relay. It's placed in series with the input circuit, terminal 1 of 2 in our slide, the fault transistor. In this way, when a fault in the field is detected, the input circuit is opened and an open circuit or a bad signaling is shown to the digital output card of the PLC DCS. Well, keep in mind that this relay is still free for normally energized application, but is still true for normally de-energized application. Well, now let's see what are the diagnostic opportunities that these two relays offer towards the field devices. Well, when the load is activated, the relay contacts are closed and it's able to monitor continuously the voltage applied to the load and the current flowing through the load. Instead, when the load is deactivated, the relay contacts are open and it's able to monitor continuously the power supply voltage and the load impedance. Well, now I want to introduce the D5294S smart relay with a fully configurable diagnostic in all its parameters. This smart relay, in addition to offering all the advantages of the smart relay seen above, adds other features such as a fully customizable diagnostics on the type of load to be used, the ability to read and write data from the Modbus via, from the module via Modbus RS 485, and offers an internal diagnostic on the integrity of the coil that make up the matrix of electromechanical relay. And finally, gives the possibility to diagnose a leakage between load and earth. Moreover, these relay modules, D5294S, support Modbus communication over an RS485 cable. Up to 127 modules can be arranged in a multi-drop network and monitored and configured by a single master unit. Each slave contains a table of parameters. Each of them is unequivocally identified through an address and when requested makes available its value for reading or writing. What are the advantages of using Modbus communication? Well, with a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible and communication can cover distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarms. This allows us to have significant saving in terms of cost and again, real-time information on the type of alarm and on the health of the load and the line. It's also possible through Modbus a complete remote programming of the relay. Well, even in this case, analyze the diagnostic section on this smart relay, checking what this functionality allows us to monitor. The smart relay is able to detect a line and load fault, both in the energized relay condition and the energized relay condition. What can we monitor when the relay is in the on state? For example, a typical application could be the monitoring of a normal energized valve. Well, in this case, we can monitor continuously the voltage applied to the load, the current flowing through the load, and for this kind of relay, also the internal coil's integrity. This specific model of a smart relay, in fact, has the possibility to performing an internal diagnostic of its coil and in the evening of a fault, report this fault to the system. What can we monitor when the relay is in the off state, typically fire and gas application, where we need to know the health of the field loop? Well, when the load is deactivated, the D5294S is able to monitor continuously the power supply voltage, the load impedance, and for this kind of relay, the leakage from the load to the ground. In this case, the relay can monitor the leakage resistance between the earth and the load. Well, now let's examine specifically the typical configuration software of our D5294S smart relay. The D5294S can be also configured when the parameters to be monitored are really specific and the alarm triggering is not achievable with the standard monitor relay. It's also possible to monitor the status of the loop in real time with the configurator through a dedicated software called SWC5019 and a small hardware interface. We can completely configure the module. For example, we can set up a window in which the values of voltage on the load, current flow in the load, and impedance of the load are included. In this way, when the measurement of the variables in the field come out of this window of configured value, an alarm is reported to the system. Through the configuration software, it's also possible to read in real time the values voltage, current, and load impedance. And in large industrial compounds, refinery, etc., for example, double coil valves are normally controlled by a single digital output driver. The double coil avoids false trip, keeping the system active even if one of the two fails. In this context, the D5294S is again an optimal solution because it can detect the opening of the single valve coil, hence providing predictive diagnostic for prompt maintenance while keeping high availability. Note that the D5294S can set impedance value between 5 ohms and 50 kilo ohms. In the next slide, let's see specifically how the relay can communicate with the system. Smart relay can report the field status to the system in several ways. First of all, the two fault contacts can be acquired by a system digital input card. This is the typical way, which implies the use of a DCS with a dedicated digital input card, where the status of a contact called a fault is monitored by the system. The second method is if the system digital output card driving the smart relay support parts testing, the fault in the field can even be mirrored directly to the digital output without the need of an additional digital input card. And again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative report from many modules is required. And last but not least, complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a Modbus master is available on the system side. Remember that through the Modbus protocol, the relay can be constantly monitored and also configured remotely. Well, and now let's see in more detail what is the mirroring function on a smart relay. This function allows us to reflect information relating to the field fault directly to the supervised digital output card of a PLC. This in both in the off status through the pulse test system and in the on state by reading the static return of current. The digital output card of a PLC can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised digital output to see the fault in the field. This system allows considerable saving in engineering cost as it allows us not to use a dedicated digital input card for this purpose. Well, I leave to Andrea to explain the difference between safety and availability. Please, Andrea.
Thank you, Massimo. So we're talking about safety and also availability, and in SIL certification, only safety is a parameter that is considered because meets the demand for functional safety on based on ISC 61.8 or ISC 61.11. 508 is for manufacturers, 511 is for the users, for system integrators. So those are the safety standard for the processing. So the device with this safe is able to perform a certain function where open close a valve, stop mode, as we've seen previously. While the availability is defined as the proportional time for which the equipment is able to perform its function. Availability is different from reliability. So we got one question from one attendee, availability. So availability is different because it's is the proportional time that the device is working, while the reliability is, of course, we can say that the item is not really reliable, but it can be required in a very short time. It became available. So its availability is high in this case. For instance, if a power supply fails with no operation, its availability is lost. So the power is off. We have developed this kind of this kind of matrix of relay where there are 4 relays working on the same load, so they are activated by the coil. So offline condition, for instance, normal energized when the relays are closed, the load current flow through the circuits and go activating the valve. In this case, that is a normal condition of the energy. When it is activated, when in the safety function is performed, it means that those relays will open simultaneously and the circuit will be open. This kind of matrix of relays is very performing in safety, but also performing in availability. So high availability while high safety. I want to say one thing more. If you look at the 52D5294S is also, as you have seen maybe in one of those slides, is able to detect the coil integrity of the single lens side. So if one relay is welded, you can still achieve your function, but the delay will indicate that there is a fault inside. So you may replace that relay or replace it without losing your safety function. Okay, Massimo, is your turn again?
Okay, thank you, Andrea. Now try to analyze some real application in relation to different types of load and the importance of the end-of-life resistors. Take, for example, a sounder. Typically, those devices, especially in the off condition of the relay, show to the later a very high impedance, often outside the diagnostic range of the smart relay. Or in the on condition of the relay, they show for a very short instant fault condition due to the capacity front end of the device. These problems often occur with this type of field devices, and to overcome them, it's necessary to insert the resistors in parallel to the device itself, which allow to bring the impedance value of the field device within the diagnostic value of the relay. In other cases, however, these field devices, again, due to their strongly inductive or capacitive front ends, generate strong reverse current peaks, which risk irreparably damaging the relay contacts. To overcome this problem, it's necessary to insert protection devices such as PTC or power resistors, able to dampen these dangerous peaks. As we see in the slide, these protection devices are placed in series with the field devices, while the end-of-life resistors must necessarily be placed in parallel and as close as possible to the terminals of the field device. The values of these resistances, or PTC, must necessarily be evaluated from application to application based on the value of the load supply voltage. Well, now analyze the two typical relay connections. The safety relays can be connected in unipolar or bipolar configuration. A bipolar connection allows a complete isolation of the load, and this is recommended, especially in application where the load must be powered with high voltage. From an electrical point of view, this type of connection grants a great safety thanks to the complete isolation of the load. In case of unipolar connection, isolates the load only one of the power supply line and brings a negative to earth in case of need. Furthermore, this type of connection saves a lot of cable cost. Only as regards the T5294S model, it's possible to configure the relay to have a diagnostic on the field device, even in condition of the load connected in unipolar mode. Clearly, we must consider the bipolar type connection as ideal and standard for an optimal functioning of the relay diagnostic. However, the D5294S guarantees, even if in a reduced way, a diagnostic of the field device connected in unipolar mode. It must be configured via software and connected as shown in the slide. In the on state, it will be able to monitor the current circulating in the load. In this way, it will provide us with information on the health of the field line, field device, and on the loop connect to it. With the relay in off state, we will be able to monitor the power supply voltage of the load. Well, we have finished the presentation on the relay. I leave.
Thank you, Massimo. So we finish this part. We start with the AS isolators and specifically line monitoring, because it's not we don't want to describe the product, but the functionality itself. So we also provide a wide range of AS isolators, illumination from different signal type and the safety parameters, of course. So your system, we call it your system because it could be wired by a single power bus system, and potentially have also a module for power redundancy and the common fault reporting. We have seen, and this is also the point of this presentation, that along with the ES certification, SIL certification is quite important. So the barrier itself has to have also, besides the SIL certifications, for assuring higher reliability for the applications. And we see that normally required now is for SIL2 as SIL when required. Line fault detection. Let's analyze different line monitoring capability by using an IS isolators. And for PLC and discuss application, of course, Analog input on the 4 to 20 milliampere equation will prove the presence of the line, and values lower than 4 milliamps or higher than 20 milliamps, of course, indicate that there is a failure. So the IS oscillator in this case a transfer from signal from 0 to 26 milliamps. So if the system is able to detect that value over than 20 milliamps, let's say, and lower than 4 milliamps as a failure, that will be transparently reported. Of course, there are number compliant transmitters that have a value lower than 3.8 milliamps in case of or higher than 21 that indicates that specific failure. And the modules indicated that the T50, 14S, 50, 58, etc., are able to transfer transparently these values in case of also fault. For analog outputs, this kind of model, D5020S, detect both short and open circuits. So for short circuit, when the load resistance detection is lower than 50 ohm or 100 ohm, that is set by dip switch, you can choose 50 or 100. The D5020 reflects the lag impedance to the system and is forcing the current to something 2 milliamps, so low current in case of short circuit. And of course, that is a detecting as fault. The system is capable to read that as fault. In case of open circuit, the load resistance is higher than is calculated by the 21 volts divided by loop current and minus 300 is a sort of calculation. But if the current load resistance is higher than 750 ohms in this case, and that will be detected as fault. And in this case, eigenimpedance will be reverted to the system, forcing low current. And that is, if the system can detect it as a fault, that it will be transferred. This module has also fault signalization, so there is a voltage free open collector transition that can be connected to digital input card of the system. In case of digital input, we developed this kind of modules that can be used for 24 digital input card. And there are this kind of resistance connected to the output that are able to generate the of course, to simulate the short and the open circuit and will be reported to the system. This is for 24 digital input card. In this case, you can, the advantage for that in case of a digital input contact, digital input signals, let's say. This kind of system can revert the fault to the system. We do have also proximity digital input card that is used like the D5034S or D is used as a transfer model as there is a current generation inside that reflect by current levels the different status. So let's say that there is a line for detection for digital inputs as well. And digital outputs as well, we have a solution that is able to detect the short and open circuit. Short in case the load resistance is lower than 50 ohms, sorry, or open circuit when the load resistance is higher than 10 kilo ohm. In both cases, the output of this module is reverted to the system side, eigenimpedance forcing low current, and that will be detected by the system if the system can detect it, if the digital inputs are supervised. Otherwise, there is fault signaling, open collector transistors that can report the fault to the system. Okay, Massimo, it's your turn again. You can discuss about the power supply.
Okay, thank you, Andrea. In the last part of our webinar, we will treat about safety power supply system. Before going into the specifics of the operation of a safety power supply system, let's see a quick representation of the products offered by GM International in this field. The power supply safety system can be composed in a rack of up to 6 elements, each of which with 50 amperes, 19-inch rack with the onboard diagnostic module, or alternatively, we can have a 9-inch rack with two 50 amperes power supply on board plus a diagnostic module, or again a 7-inch rack without a diagnostic module. All our rack allow the redundancy of the power supply modules to obtain different working configuration. Finally, it's possible to obtain single modules of 50 amperes or 20 amperes, which can be placed in parallel to have up to 10 modules connecting in current sharing between them. Well, but now let's take a look at the power supply. What are the possible risks and conditions that we consider dangerous in relation to the use of power supply? The concept of safety is very important also with regard to power supply system, because the failure of a power supply can cause serious accidents that lead to serious losses in terms of human lives, serious environmental damages, and serious cost losses for companies. For this reason, it's necessary to have safe devices that guarantee high performance. But what are the dangerous conditions for a power supply system? Well, mainly there are two dangerous fault conditions. The first one is an undefined load voltage in a range between 2 and 20 volts, must be considered as dangerous failure of our power supply. This is because an incorrectly powered load works or can work out of specification, and this leads to a reduction in a load performance that can cause a premature instrument failure. Often we try to avoid this issue using redundancy, but we wrongly think that two power supplies in parallel are sufficient to make us immune from possible faults in the power supply system. Redundancy cannot solve on its own and cannot guarantee us immunity from power supply failure. Because a standard power supply system, it does not take into account the common mode faults that can afflict standard power supply. These common mode faults can cause spurious system faults with their related production downtime, which would significantly affect cost. The redundancy of safety power supply minimizes this risk because common mode fault failure are considered in the SIL calculation necessary to get the certification for a safety-related device. The second dangerous failure condition of a power supply is when the output voltage reaches a value higher than 30 volt. In this condition, the load is subjected to extra voltage, which can damage it. Or in case of output voltage higher than 50 volt, the field instrumentation can suffer a definite disruption. We can take, for example, an engine cooling system, which works thanks to a standard power supply. Suppose that this standard power supply fails and goes into an overvoltage condition, damaging the cooling system. This will lead to an overheating of the engine, which will lead to serious consequences for the whole system connected to it. A safe power supply system grants high performance and high safety. So why it's correct to use a separate power supply system. Below are the main reasons that lead us to advise against the use of simple standard power supply. A standard power supply is not designed based on the directive of ESC 61508. It does not have made a calculation defined for the safety function to be obtained. It does not allow to have redundant protection from overvoltage issue, while in a separate power supply system, redundant protection are fundamental required. And again, standard power supplies can be used in a redundant configuration, but they do not guarantee that our application is totally safe, for the reason related to common fault, mode fault, which we have seen previously. And also, power supply often require external O-ring diodes for redundancy. This means to add external wiring that, especially for high load currents, creates a high voltage drop, which has a strong impact on the supply voltage. It's true that it's possible to adjust the output voltage to compensate for the voltage drop, but this operation increases consumption considerably. In addition, a standard power supply has a higher number of spurious faults than a separate power supply. We know well how a spurious faults can also lead to dangerous failures for the application. And also, standard power supply use internal components with limited operating range to keep the cost down. This affects the lifetime of the device. For this reason, internally to the safety power supply are used components with an higher operating range that allow the system to work at a lower stress level. This leads to less failures and consequently considerably longer lifetime than a standard power supply system. But at this point, why it's important to use a separate power supply system? First of all, we know that the standard voltage for a normally energized load is in the 20-40 volt DC range. As we have seen previously, conditions that lead to power supply output voltage between 2 and 20 volts and higher than 40 volts are considered dangerous failure, which negatively affect the application. Well, a separate power supply significantly reduce undetected dangerous faults thanks to a built-in diagnostic system. In fact, if an anomalous output condition is detected by the separate power supply diagnostic, it brings the output to 0 volts, which represent the safe fault condition. Plus, a fault transistor alerts the PLC system, which can act as per specification. Well, in the next slide, a huge advantage that separate power supplies give is the presence of the O-ring diodes inside the device. This grants a huge cost advantage, as it not necessary to externally wire the diodes for each unit that is part of the redundant power supply system. GM International power supplies do not request external O-ring diodes for output parallel configuration because each GM International power supply has got internal. And this kind of system have an active ideal diodes realized by MOSFET and related control circuit components, replacing old metal with Shockley or ring diodes. This increase efficiency, reliability, and durability, and reduce space about not use Shockley diodes heat sinks. MOSFET active ideal diodes with a related control circuit provide also very smooth voltage switchovers without oscillation with the fast turn-off, minimizing reverse current transient. In the table, in the next table, we see advantage that the ideal diode system inside a safety power supply system brings compared to a standard power supply. The mainly advantages surely are the voltage drop at 50 ampere, 0.06 volt for GM International system against 0.8 volt with all the Shockley diode system, or power dissipation, 40 watt for the old system against 3 watt in case of GM International system. Now, the next slide, this purely hardware control is complex and based on the output current measuring that each power supply module executes. Typically, load current sharing capability is a necessary feature for medium and high load current. All GM International power supply can be paralleled on their output and their internal load current sharing circuit operate to distribute current load equally to each power supply module to increase reliability and reduce internal power dissipation of each module. And to finish, another advantage of load current sharing functionality is a request of little system output voltage modification when 2 or more PS modules are normally operating. The last feature is the short circuit proof system. This system avoids that in the event of a short circuit of one of the loads connected to the power supply system, there is no system shutdown. In fact, when the protection circuit detects a short circuit on the line, it sends a current peak that can reach up to 800 ampere for a maximum of 0.5 milliseconds, able to interrupt the protection fuse or the circuit breaker associated with it to interrupt the power supply to the short circuit load and safeguard the rest of the system. Well, Andrea,
thank you, Massimo.
Our presentation.
Still have some attendees waiting. We finished our webinars today. You may find other documentation details about our products and our website. Website also available for certifications, product details, manuals, whatever software, whatever you need. It's time for your question. Now, if you have just type, raise your hand, whatever you like. It's, if you don't have, of course, we can go on. Maybe you have it, but it's, let's say, exceed the time, as I say, there's a 1 hour and 5 minutes, a little bit more for this webinar. And don't hesitate to write us. I want to remind you that we still have a live webinars calendar, which is available on our website. You can find you can find to our website all topics. New topics will come for the next month, so stay tuned, please, because we will discuss about maybe IS solutions and probably don't know. We're still discussing about that. You can find this webinar and other on our YouTube channel. The link is now on our website. So you can share, use, receive with your colleagues and send to them. We have a question about the certificate. You will get a certificate for this webinar if you participated, so you will get it. And last not least, I want to launch this new poll regarding the rate. So we are also evaluated on that. Please write what you like and how we did. If it was one of the first time for us for this webinar, this topic, I think is more application related. Thank you for voting. Don't worry, you will be anonymous. You can write what you like. Don't be afraid. And thank you for participating in the game. And that's perfect. Thank you very much. I want to stop in a few seconds in order to stop the session. Thank you to all of you. And let's stop now. And we remind you our names, and please don't hesitate to send us to phone us whatever you like, and we'll try to answer to your question.
Andrea, I think we have a question from our attendee.
Okay, we can close with that, please.
Just for you, regarding the cost of the SIL power supply. Currently, the cost of SIL2 rated loop is around twice a no-SIL rated loop in absence of regulation and enforcement. Do you think widespread industrial adoption of SIL would increase sales to the point where equipment cost would reduce significantly? And how can functional safety engineering and validation costs be reduced?
It's complicated and longer things. So the thing is SIL rated and non-SIL rated loops. Of course, operators and therefore more likely do not to use non-SIL rated kit. Of course, non-SIL rated kit are preferred if possible because the cost is completely different, and also there is a cost for installation, there is a for purchasing, there is also a cost for maintenance because there is a testing proof to be put in place for each equipment. Do you think a widespread industry adoption of SIL globally would increase sales to the point where equipment costs would reduce significantly? It's a good question. It's SIL is something that will think we have the experience with the EX, we experience with the SIL, and the SIL is something that is only used in cases needed. People don't use SIL, want to use SIL, won't be an obligation for the future because it's only, the SIL is only demanded when it's required by different other aggregation like environments organizations, or maybe assurance and so on. Those people can force to go to the SIL used for the products. Otherwise, the government won't make that an obligation. It will be used only in case you will get any benefit in terms of environment, and you will be forced by that. In terms of cost, you will be forced by assurance. So your cost will go down because you are going to have a more safe plant, more safe systems. But it's a challenging situation. I think we can stop now because otherwise it's making boring for all of you. Maybe if this attendee want to discuss in details, you can write again to us. Thank you to all of you. Thank you, Massimo.
Thank you, Andrea. Thank you, our attendees, and see you in the next webinar.
Perfect. Stay tuned. Bye. Thank you.
Bye-bye.